Good morning, everybody. I'm speaking on behalf of New Technic. We are design engineers, and we specialize in the design engineering of buildings. So we specialize in structural engineering, facade engineering, and environmental engineering with the emphasis on design. So how do we deliver design? And that is through various tools. One of those, the one I'm going to talk to you about this morning, is BIM. Now, Martin's spoken about BIM and where it's going. So I want to show you some slides about who we are. We work on projects around the world. We work for half our work is with high-profile architects. The other half is with big contractors. And I want to talk about the two parts. There are two parts to BIM. One is design, and that's design teams, which is mostly what we're involved with. The other half is implementation, execution, how we build from the BIM models and outputs that we create. So this morning, I'm going to focus on, because we only have 20 minutes, so I'm going to focus on the part which is to do with the design tools and talk briefly about their implementation there, the consequences which we're all going to be facing and enjoying and dealing with and benefiting from during the execution stages. So one of the things that we do is write books. And it's quite important to maintain an authority in the field. So we write university textbooks to use at leading universities around the world in architecture schools and engineering schools. And the point is to be able to establish yourself, to be able to understand what the current technologies are. So in books we write about current technologies. We have 7 offices around the world, and we've got 2 established in the UK, and we've opened up 5 others around the world, and they're all linked to leading universities with strong engineering departments where we can do prototyping. So the proof of the pudding is prototyping and testing before you get to the bidding stage, before you get to the tender stage. I'm just going to show you briefly some projects that we are working on. So that is how we work before. You saw with the completed projects, that's how we were working. This is how we are working now. So at New Technic, we are attempting to build the future now. How do we do that? Through our processes and through execution. So talking about how we work now. So this is what's going on at the moment. We're all building 3D models, and those are often models which describe something which cannot be described in 2 dimensions. I think for anybody like me who started doing summer jobs as a draftsman, it was always extraordinarily frustrating drawing something where you had to learn the code for expressing a building, a detail, a layout in a kind of codified way that somehow everybody could understand. So you would draw one detail, but you knew you needed to draw 500 details. You had to have something that was a typical detail, but you didn't know what it was typical of. It was always frustrating. Now with 3D models, we can describe not just something which is extruded, but something which is non-linear, something which has a complex form. So we're obviously no longer restrained by the idea of taking a plan and knowing that the 2nd or the 50th floor is going to be in the same place in space, but vertically arranged in the Z direction. So this is how we're all working at the moment. We're tagging bits of the model, we're tagging bits of the building. We just have a rather unclear relationship between the model and the 2D drawings. So we're trying to address that through 4 themes I'm going to talk about in the next 20 minutes. By the way, all these slides I've got notes on. They will be distributed to you after this. This will all be available to you for download, so you can read it all at leisure and get a second bite at all of this stuff. So what we do with our work is design the hell out of it. We describe as much as we can because we want to reduce risk. We want to reduce risk for the architect or risk for the contractor. So we describe everything in as much detail as possible, and we managed to do that through having written books, having worked on a lot of projects, which are at the leading edge of technologies for construction and leading technologies for describing the processes. So here we use finite element analysis, which is linked to the 3D model. It's linked to the BIM model, because unless you know how big something is, there's no point in really an engineer drawing it. And what are we drawing it for? We're drawing it to optimize it for weight. Primarily, as engineers, we want to reduce the weight of something. How do we reduce the weight? Well, we draw the hell out of it and find out how thin it can go. But we are only largely at the design stage. We're optimizing for the weight of something, and we can do that by giving, where possible, a double function to something. So where in automotive or aeronautical engineering, it's quite standard for a component to have two functions. In buildings, we tend to like to have one function for one thing. So everything is part of a diagram. So by combining and pushing stuff all into having multiple tasks, multiple functions for a single component, we can start to develop our own technologies. So this was developed in conjunction with the engineering department at Cambridge University, where we are industrial partners. And this is a permanent formwork proposal for a big project in Egypt, where the formwork is the cladding. So obviously it's quite frustrating having cladding that you bolt on the outside of a facade. It has a slightly, it sort of lacks authenticity because it's not working very hard. It's protecting the membrane largely, protecting the building from long-term damage and providing a weathering membrane. So we've combined it so it's actually part of the construction process. Now, that has big effects on first of all, its resistance to the wind blowing at it, and also the thermal transmission from outside to inside. So the softwares that we use are linked so that we're able to largely optimize for what the design team wants to do, which is to reduce cost. So when we're working for architects, cost is primary, and reducing the weight, reducing the numbers of components is a way of saving money. When, as Martin mentioned, there's a transition to execution, then the priorities change. So here we are looking at optimizing for manufacture. So what are the things which you are looking at for optimizing for manufacture? It's for the execution on site, which is reducing waste, ensuring that the building is safe, increasing productivity, and increasing quality. So we want greater certainty. We want to avoid problems, clashes on site. So the stuff that we're looking at here at the design stage is clash aversion. So rather than clash detection, clash detection is a kind of a consequence of an imperfect process from our point of view. What we are doing is clash aversion, and we are using coordinated BIM models for that role. So we use finite element analysis tools. We use CFD, computational fluid dynamics, for the flow of fluids, gases, and we use geometry models to be able to put things together. So really, there are two aspects to sort of a future of BIM modeling. Apart from optimization for design processes and for construction processes, we're also looking to understand how things flow. So in the structure, you want to know how the forces flow. In an environmental, when you're looking at the environmental design, you want to know how the energy flows. It's about flow of forces, flow of energy, and a flow of geometry. So how, when things join together, what do they want to do? What are they trying to do? That's the sort of way into optimization. So we do a lot of development of facade systems and structural systems, primarily connections for structural systems. And here we've got at Cambridge the mock-ups for these are for GRC or GFRC in the US. So GFRC panels being used on a big tower here in Istanbul. So there's a tower which is a big concrete tube, and we're putting cladding on the outside to follow the intent of the architectural design. And to do that, we need to lift big panels, which are these guys here. So these are pretty huge panels, and they are sitting on an adapted unitized panel system that's that was conceived primarily for use as a curtain wall system. So we're combining lightweight curtain wall systems with heavy concrete panels on the outside. So in some ways, we're taking some of the dreams of the 1960s and we are bringing them alive through documentation, which we were not able to do before the arrival of BIM. Certainly, the big move on just from 3D modeling to BIM has been a huge change, where we're able to encapsulate a lot more information, obviously, in a 3D model. That was a sensational change, and its developments are heading now onto building sites. So here there's a mock-up which was made from a regular 3D model. It was then worked up as a BIM model here, and some views from the physical mock-up. Now, the physical mock-up is really only possible as a result of being able to describe every single component and how it's working inside that 3D model. Now, dashboards. So we're going to show really a slide here. Assembly technologies. How assembly is going to be described in the coming years? Well, dashboards is a big thing. 2017, the big thing was exports. How to export something from one package to another. That is very kind of 2017. 2018 is really all about dashboards. How to have multiple amounts of information on the same interface. So here we are using in on our projects 3D views and associated data of those panels. Now, now the software is being developed, and we are customizing the hell out of our own versions of these. Softwares are arriving, which have been developed over the last 24 months, which combine the 3D model with the program at the bottom. So there's a big picture similar to this kind of dashboard here. So there's a picture. There is the 3D model. There is at the bottom the program, and on the right there are outputs of costs. So as you alter the 3D model, it tells you the impact on the construction program. We want to reduce construction programs, not because it's quite nice to, but because it makes a difference between somebody losing a shed load of money on a project and breaking even or making money. So building construction is high risk financially, high risk for people working on the site because it's a dangerous job. Very important that the relationship between understanding the way that these projects are evolving is to have moving towards a dashboard where at the design stage you can see the model, the effect on program, and the effect on cost, and then during the execution stage, the effect on moving things around the building site, the effect of bringing things too early, the effect on moving things into places which cause danger. A lot of people are injured every year. I think there are 3,000 serious casualties in the US alone every year on building sites. Whenever I've been on a building site, somebody gets injured. Somebody's walking around thinking this is all nice fun walking around with a hard hat. It's dangerous, and recently somebody was injured quite seriously, but not being aware of where they were. So safety for everybody is quite an important part of the site application of these technologies. So one of the things that we do at New Technic is develop, as I was saying, develop facade systems and structural systems and connections which are developed, which are prototyped and tested at leading universities around the world, so that by the time we get to the stage where we are at the bidding stage, at the tender stage, we already have geometry, we have assembly, and the components are already modeled. Like everyone else, we're making as much use of Grasshopper and Dynamo as possible with Revit, and we're using primarily Grasshopper where we are developing it with other softwares. So here you can see the kind of the way things are going with the interface. It's got some text added on for the purposes of you to be able to read after this presentation. But the way things are going is to have the 3D model, program information. Here we have assumptions, design assumptions, structural assumptions, and then here we have the effects on changes through the program and the effects on cost. So the dashboard. There's quite a lot of development in the US of dashboards at the moment, not just in Silicon Valley, but in pretty much any town across the US where people have got ambition to change the way we build. And we are doing all that because building construction is quite low, has quite low productivity, and it's still the last cottage industry. When I started in my first summer job, I was told, welcome to the last cottage industry. It won't be like this by the time you graduate. Well, I graduated and it was the same, and 30 years on, it seems to be pretty much the same from the execution point of view. So we're getting better tools, but we're still quite limited in increasing productivity, having that link to construction. And these dashboards with associated data is going to be a key way forward in comparing modeling with time. So it becomes 4D, not just for fun, but to be able to reduce construction time, reduce risk, reduce cost. So the less time people spend on site, the less risk they have of being injured, the less money is being spent, the less noise is being generated, the less everything is being wasted. So here's a project in China, recent that we design engineered the facades for. It's just been it's completed in the last 6 months, and here we were doing both the close coordination between the structure, the environmental control through the facades, and the assembly of the whole thing. Now, what is another big change that we're seeing is the use of VR, so that meetings, we work on projects across the US, now we're just getting going on those, and a big tool is going to be the use of headsets like a HoloLens headset that seems to be commercially the most straightforward for everybody to use. The point being that we're then able to view these kinds of we can view these kinds of projects from the perspective of how things are going to be constructed. So we are moving now so that when you work with these kinds of dashboards, if you click on this, the specification comes up relating to that part of the project. Now in BIM, we're obviously seeing metadata that's able to tell you, that's able to essentially link drawings to a 3D shape to a specification. But now the HoloLens, the VR and an AR, or the Augmented Reality kit, is now allowing us to be on a building site, do the standard walk round, and compare it with the 3D model. So the specification comes up in front of you when you're on the screen, when you're using the headset. So if you're looking, once you've got over the business of not falling over with the thing on, then if you are looking at a piece of steelwork, it will come up with color red. If it's been painted green by mistake, it will simply tell you. You don't have to live on your wits and a deep understanding of the specification. You don't have to be a walking encyclopedia of the project. You can simply refer to the pop-up menu that tells you what's happening on the project at that point. That is then we're able then to link that back to the finite element analysis of the project, so we can step back from the processes of installation. If somebody says, I need another big thing hanging off this piece of structure, what can we do? So rather than start all over again, we're able to go back into the finite element analysis models, the FE models, and be able to interpret what the results were. So a big tool that is helping there's helping BIM tools, there's helping geometry tools. A big thing is structural analysis. Now, there are changes over the last 10 years in structural analysis, as there are in CFD, which is that you can do big global analyses of structures and buildings, and you're able to do them locally and globally. While we're on this slide, you can see how the future, I think, is shaping up with a 3D model, linking it to the construction program, linking it to costs, and giving you specific data about why things are the way they are. So there's the link between this global analysis, global information, and in structures we're looking at displacements, primarily on big stuff, how much it bobs up and down, and locally at connections we're looking at stresses, the amount of force per unit area, how much punch is something receiving locally. Those are kind of headline things that we look at in early stages of structural design and environmental design. Flow of forces, flow of fluids. There are big changes coming ahead, as I'm sure you're all aware. This is a project that is under construction at the moment in Riyadh, a metro station, and the building is likely to be maintained and monitored by drones. Now, in the coming years, drones will be used to both monitor something and to understand the long-term behavior of a building, understand the long-term performance of something. Like an earthworm, you're sort of looking at how it wiggles and wriggles and how a simple structure is able to change direction, put food in at one end and dispose of it at the other, examining the behavior of a relatively simple structural system, which is a building. We see increasingly robots being used to build buildings, and drones being used to monitor and manage some of those processes. Now, there's a lot of talk at the moment of things being, there's a lot of action at the moment with pushing everything towards prefabrication. So we do BIM models, we do complete descriptions, a digital twin, if you like, of a building, and we hand it over to someone in factories. So somehow everything's going to be made in factories. We don't see it that way at all. We see that building construction still retaining a mixture of site-based activities and factory-based activities. So what is worth prefabricating is made in a factory. What needs to be put together on site will remain to be done on site. But as forms and buildings become more complex and we seek safer working conditions for those working on those sites, then machines will increasingly take over that role. So we've proposed construction labs, which we're using on a couple of projects where detailed fabrication is happening on the job site, on the building site itself. Now, there's a big circular building in California that is rather good, and that has a mixture, that was constructed with a mixture of site-based and factory-based activities. So there has been no, even on cutting-edge buildings, there is no slavish adherence to the concept of everything being done off-site, because somehow that adds quality and somehow everything ends up better. And you put things together as a sort of Lego kit on site. No. It's happening and is going to continue to happening as a mixture of site-based activities and factory-based activities, things suiting what they are good at. So what is currently being done on site is heading in this direction, where specialist fabrication facilities are being put on a building site. So building sites will no longer remain kind of places which are rather alien, places where you have a rather dangerous, uncontrollable environment where you try and do as little as possible. It's a place where increasingly people are going to be making things. So a return to pre-industrial construction, where with getting machines to do the jobs that we are unable to do on a building site. So just as in the Middle Ages, pulleys and ropes and block and tackle were used to lift big stones. Technology was used there where it was needed. Things were made off-site, things were made on-site for large public buildings and religious buildings in the Middle Ages. So we're returning to that, but with better tools that can help us do the job, not machines which will do the job for us. So it's to help us, as in the pre-industrial world, to help us do all the jobs that we need to do. So we're moving away from a BIM model, which is a complete digital twin that you hand over as a precious finished object for someone else to sort out in some unspecified way, but we're increasing, as Martin mentioned earlier, linking those to construction. Now, there's a whole other presentation which we can do on how those tools are interpreted for construction, how they're used during the construction stage, but this is just a quick run through how things are used during the design stage when design teams are preparing documentation for tender. Now, one of the big things that this is heading towards are these simulations of construction. This is done using this specific output is from Sophistic. A great FE tool, and here we're able to show how the way that a structure is built can be reduced, can be optimized, reduced for time, reduce the amount of time it takes to build something. So part of that is in the design itself. So we're using a big, strong concrete box and then putting a lighter steel structure on it. So we get the combined benefits of steel that's very springy and arches that want to flatten out, and a big, heavy concrete box which is underneath it. So we're getting combined benefits of different structural systems, and so that gives us the basis for being able to describe with certainty how buildings are going to be put together. I think that's my 20 minutes. Okay. So thank you very much.